Hello, good morning. It's my pleasure to be back with you in another math session. Today we're going to continue working on our Unit 6, fraction concepts and operations. Our teaching point for today will be, I can add and subtract fractions with like denominators. Today is Tuesday, May 12, 2020, and our lesson for today is titled, Add and subtract fractions with like denominators. I encourage you to pause the video now and get to copy the date, lesson name, and teaching point just before we get to work on our quick practice. Alright? So in our quick practice for today, we have an anytime problem. This is basically a problem just to play a little bit with math. So let's see. The sum, it is to say the total, of three consecutive whole numbers, that is three whole numbers in a row, let's say 2, 3, 4, or 25, 26, 27, consecutive numbers is 105. So what are these numbers? Basically, you're going to be looking for three consecutive numbers that when you add them, you get 105 as a result. I hope that you have fun trying out this activity. Today, I'm not sharing the answer with you. If you can actually figure this out, you can tell me and then I will share the answer with you. Alright, since our teaching point for today is I can add and subtract fractions with like denominators, then that means that today we're going to be working with fractions that have the same denominator. And that's what we have right here. We have two ways to actually call this situation. It can be common denominator or like denominator. Alright? So what is basically that? A common denominator is when two or more fractions have the same denominator. If you take a look at these two fractions right here, they share the same denominator. They have the same amount of pieces being divided. Then only when we have like denominators, we can add and subtract fractions. Right? Keep that in mind. Only when we have the same denominator, then we can operate fractions. In this case, we're going to be adding and subtracting. All right, so we have these two fractions. We have 3/8 and we have 4/8. And we're going to add them. If we make a model to represent the two fractions on the left side, we will have, or actually on the first adding, we will have 8 equal pieces right there. You see, because we have 8 pieces in our denominator. Now, in our numerator, number at the top, it says that we're supposed to highlight 3 of them. All right, so far so good. On our second addend, second partner, then we have the same 8 equal pieces. So what I'm going to do is that I'm going to divide my rectangle into 8 pieces as well, and then I'm going to shade 4 of these pieces. So far, we have identified, actually represented the two fractions using a model. Now, if we add them, we're basically taking the same model. When we talk about like denominator, for example, we are actually saying that, or actually talking about the same piece. It's like we have this total at first, this array right here, this big rectangle, and then all of a sudden we took out different pieces. What we're trying to do now is to get them together. Like denominator means that we're talking about the same piece, all right? So this is 1, this is the same. And right here, we're talking about different pieces inside those 8. So if we add these two fractions together, you're going to see that we had the 4 square that we had shaded at the bottom on the second item right here, and the 3 ones that we had at the top on the first item, right? If we count all the squares that are highlighted, then we say that we have 7/8 as the fractions that resulted from adding these two fractions. I want you to take a look at something. This right here didn't change. The denominators stayed the same the whole process. So that means that when you're adding fractions with like denominators, the denominators never change, right? It just stays the same the whole process. The only thing that changes is the denominator, the number on top, denominator. All right, if we represent this without the drawing, this might look like this. Then we have our first addend 3/8 plus 4/8. That is equal to 7/8. Yet again, the denominators stay the same. The only thing that we did is actually add 3 plus 4. And since these were nominator, then I place them in the nominator place as well. We have another way to actually represent this. Since we're talking about the same denominator, it would be the same as having this right here. As you can see, I added this piece of information where we have the same process that we did mentally, let's say, that we added in this case 3 plus 4 and then we jump in to 7. We just added this step in where we add 3 plus 4 at the top because at the end that's the number that we're getting at the denominator's place. And then at the bottom, since we have the same like denominator, then it's just staying the same, right? So basically this step right here is going in detail to show the process that the denominator is going through. However, if we take a look at subtraction, we're going to try the same three fractions. This time, from the total that we got, we're going to be taking one of the addends. Right, so we got 7/8 and we have 4/8. Right here, we're going to represent the fractions as well. We still have the same pieces, 8, because we still have the same denominator. Right here, we're going to have 7, and on this one, we're going to have 4. If we subtract this, yet again, the denominator stays the same, and the only thing that will change is the denominator. 7 minus 4 equals 3, and that's why we got 3/8. In this case, instead of adding shaded parts, we're going to be taking shaded parts from this total that we have right here. If you take a look, we're taking away 4 shaded parts from these fractions right here. So at the end, we only have the same 3 pieces that we had at the top. Same situation with addition, we're going to have it with subtraction. We have 7/8 minus 4/8 equal to 3/8. Yet again, the same step that we have with addition, where we are going detail explaining what we have for the denominator. We have 7/8 minus 4/8 being represented right here. Instead of jumping in right away to this answer, we're going to be including this step to show the process that the denominator goes through. Remember, the denominator, the number at the bottom, always stays the same. The only thing that you're trying is either adding or subtracting the denominator, the number that we have at the top. In this case, we subtracted 7 minus 4, that is equal to 3. Alright? In our independent work for today, we're going to be working with 3 pages. You're going to be having a lot of fluency practice for you to get skill on adding and subtracting fractions with like denominators. We're going to be working on the pages 259, 260, and 261 from your student activity book. First, you're going to find this situation. So on the first one, you're supposed to take a look at this fraction bar. So we have one addend selected right here, and the second addend selected right here. So first you're going to complete these 2 fractions, and then you're going to write denominators right here, and then the total here. In this case, you already are given the fraction, but you're supposed to write the denominators on top and then the total right here. So what happens to the denominators in each equation? What happens to the denominators in each equation? If you pay attention to what we said before, then this might come easy to you. Right, subtracting, same thing. We have this selection right here. We have 1, 2, 3, 4, 5, 6, 7, right? So on the first case, from this 7, we took away two fractions. So what we will have? The same thing. Identify the fraction and just include the denominators that were missing. We have more of the same right here. What happens to the denominators in this equation and how is subtracting fractions with like denominators similar to adding fractions with like denominator. So between these two, when we subtract and add, what is the same thing that they share? And yet again, we got some more fluency exercise. This probably might not take you this long. At the end, we have our puzzle penguin that is a little bit confused on how to operate fractions with like denominator. As we can see right here, he added the two denominator. Is he correct? Help him out. Same thing. In the case of subtraction, he subtracted the denominator even though they were like denominators. So you're going to write a response to Puzzle Penguin explaining why is he wrong, why is he right. And that will do it for today, guys. I hope that you have enjoyed this lesson. Remember that if you have any doubt, let me know, and I will gladly answer to you. So see you next time. Bye-bye.